Every app you love runs on a database. Pick the right one and your product flies. Pick wrong and it stalls. Strip any app to the studs. Rideshare, banking, TikTok, even your thermostat, and you'll find the same beating heart. A database. Simply put, a database is a structured collection of data, managed by a DBMS, the operating system for your information. It stores, secures, and lets you query data efficiently. Why it matters. Your choice affects performance, scalability, cost, developer speed, and data safety. Today's databases handle both neat tables and messy JSON, so you can evolve as products change without sacrificing reliability. What do databases actually enable? Fast lookups at checkout, accurate money transfers, real-time dashboards, and smart recommendations. A helpful split. OLTP handles lots of tiny reads and writes for apps. Think placing an order. OLAP tackles big, crunchy queries across huge datasets. Think sales trends by region. The two often work together. Your app writes to an OLTP store, while analytics and BI read aggregated snapshots or replicas. Keep that mental model handy. It guides designs, index choices, and when to separate workloads. Relational databases, RDBMS, organize data into tables and enforce rules with keys and ACID transactions. They speak SQL and shine at consistency and complex queries. In 2025, they're anything but old school. MySQL adds JSON validation, vector types, SQL support, and SHA-3. PostgreSQL expands JSON functions, replication, and vector search via pgvector. Enterprise stalwarts push multi-cloud resilience. Why teams love them? You get mature security and tooling plus modern features like JSON, vectors, and logical replication, all deployable on cloud-native platforms. NoSQL isn't one thing, it's a family. Document stores keep JSON-like documents for content and profiles. Key value stores deliver blistering speed for caching and sessions. Wide column stores handle huge, write-heavy workloads. Graph databases map relationships for recommendations and fraud. In 2025, features leap forward. MongoDB ships disk ANN vector indexing and enterprise SSO. Cassandra adds vector types, new indexes, and masking. The trade-off: fewer rigid constraints, more flexibility and scale. Perfect when schemas evolve quickly or throughput needs are extreme. Cloud databases, DBAS, manage the heavy lifting, patches, backups. Scaling, high availability, so teams can ship faster. Think Amazon RDS and Aurora, Google Cloud SQL, Azure SQL Database, and MongoDB Atlas. Benefits include automatic failover, read replicas across regions, pay-as-you-go pricing, and tight DevOps integration. Serverless standouts like DynamoDB scale invisibly and offer global tables and continuous backups. If operations isn't your core business, managed services deliver reliability and velocity without burning time on maintenance. In-memory databases keep hot data in RAM for ultra-low latency, perfect for pricing, personalization, and real-time analytics. Redis, HANA, and SingleStore exemplify this speed. Distributed SQL blends relational consistency with horizontal scale and global replication. CockroachDB and Spanner give you ACID guarantees across regions. In 2025, that means SQL you love. With the reach you need, strong consistency, survivable failures, and predictable performance, even when traffic spikes or users span continents. Time series databases specialize in events over time, metrics, sensors, logs, market ticks. They optimize for high-rate throughput, compression, and time window queries like rolling averages and downsampling. InfluxDB and TimescaleDB on Postgres are popular picks. Use them when metrics explode and you need fast ingest plus efficient retention policies. The payoff? Smooth dashboards, quick anomaly detection, and storage that doesn't balloon as data ages. Specialized databases fill sharp needs. Ledger databases keep tamper-evident histories for audits and compliance. Search engines like Elasticsearch and OpenSearch excel at full text, logs, and dashboards. Vector search indexes embeddings for AI, semantic search, and retrieval augmented generation. In 2025, vectors are built into mainstream systems. Postgres with pgvector, MySQL vector types, MongoDB discan. Cassandra vectors, often removing the need for a separate vector store. Choose integrated when convenient. Go dedicated when scale or features demand it. Real systems go polyglot. Pick the right tool for each job. An e-commerce stack might use a relational DB for orders and payments, a document store for product catalogs, a graph or vector index for recommendations, and a time series DB for live metrics. FinTech blends ACID ledgers, graph fraud analysis, and Redis for low latency limits. IoT pipelines flow into time series, wide column stores, and search for logs. The secret: clear data contracts and strong observability at the seams. How to choose: start with your data model, then decide your consistency needs, strict versus eventual. Map your workload, OLTP, OLAP, or mixed, and consider scale, latency, operations, cost, and compliance. A pragmatic starter kit: PostgreSQL for most apps, Redis for caching, DynamoDB or Cassandra for predictable high writes, a time series DB when metrics surge, CockroachDB or Spanner for global ACID, and add vector indexing for semantic search or RAG. Avoid trendy for trendy sake choices, weak schema design, and skipping backups. If this helped clarify the database landscape, tap like, subscribe for more practical architecture guides, and drop your questions or stack choices in the comments.